Hello guys, welcome back to Maths on African Motifs. Still working on our Euclidean geometry. This is one of the most important topics that we have, that we are supposed to actually understand the properties of your shapes, the theorems that you have in your syllabus and so forth. So we are not going to waste much time. Let us quickly rush through our questions. As we can see, this is a past exam question that you're going to attempt on question number 5, where we are given 5.1, complete the statement. All right, so this is the statement that you're given to complete. If the opposite angles, take note, if the opposite angles of a quadrilateral are equal, then the quadrilateral is, all right, a quadrilateral, you're talking about a polygon with four sides, okay? Any polygon with 4 sides. But for the fact that the opposite angles are equal, this can happen on many many quadrilaterals. But of these quadrilaterals that we talk about, the branch name or the mother name of this is going to be a parallelogram. All right, parallelogram. Remember, a parallelogram, it has the properties which are used or which are applied, one, on a rectangle. It has properties which are to be applied on a rhombus. The properties which are to be applied on a square, all these, they are taken from a parallelogram. So the parallelogram is the mother quadrilateral of these quadrilaterals. So that is, instead of you writing a square, a rectangle, just going to have it as a parallelogram. Okay, I hope you understand. 5.2, in the diagram below, A, B, C, D, this whole part is a quadrilateral. So you're not told, is it a parallelogram or you just told it's a quadrilateral. All right, let's see what we have. E is a point on AD, this point E, so that A to A is equal to AB. AE is equal to AB. These two sides, they are equal, okay? So you can see the indication of this shows that these two sides are equal. So if they are equal, what it means is that the angle at B from the opposite sides, right, like this, from the angles that are opposite equal sides, it follows that these two angles will be equal. The angle opposite B, which is E1, the angle opposite AE, which is B1. So this angle B1 and this angle X, E1, they will be equal. All right? These are angles that are opposite what? Equal sides. So they must be equal also. It is the same thing also from EC and CD. From C, EC, this one, the side EC, this side, and the side CD, these two sides, they're equal. As you can see from the indication here, these two sides are equal. So it follows that the opposite angles must be equal. So 2x must be equal to angle E3 from the same theorem that I explained. All right, or from the same concept that I explained, that these angles that are opposite equal sides must also be equal. And we're given that AD, from A to D, it is parallel to BC. So as you can see here, BC and this side AD, they are parallel, yes. And we're given, let the angle D be equal to 2x and angle B1 be equal to x, as we are given here. All right, so that is the information. And this is just a quadrilateral. We're not told, but we just told they are parallel. And we're not told it's a rhombus, it's a parallelogram, or it's a what. You are supposed to prove that later on. So you do not know. So you answer this question as if you do not know the shape that you're given. All right, 5.21. Determine the value of x. All right. So this is what you're going to have. Let us just calculate it here. To have the value of x, we can use so many ways. Already here, from what I've indicated before, that this is x and this is x. we can actually take advantage of the straight line. Remember that angles on a straight line equals to 180 degrees. So if I add this x and this angle E2, which is this right angle, this is 90 degrees. Remember, right angle is 90 degrees. And this 2x, I'm supposed to get what? 180 degrees. These are angles on a straight line. All right, so we've already indicated E. So we indicated that angle E1, let us just write it down. Angle E1 is equal to x. All right. Also, we indicated that this angle E3 is equal to x. Angle E3 is equal to 2x, not x, but 2x, all right? Remember, we indicated this. So E1 is equal to x from which concept? Remember, I was explaining from the angles that are opposite equal sides, all right? These angles that are opposite equal sides. So these are angles, all right? So we have got angles opposite, let's just write in short, angles opposite equal sides. So this is the same thing that is happening here. All right. So the same thing is just a repetition here. Just gonna write the same reason. So this is the reason why we have this x here and this 2x on E3. That is the reason that that's why we have this. But like I was explaining, that we want to take advantage of a straight line, that angles on a straight line add up to 180 degrees. So if I add x plus this 90 degrees at E2 and E3, which is 2x, I'm supposed to get 180 degrees because I'm talking about a straight line, angles on a straight line. So these are the angles making up the straight line. Here, we are talking about making up a straight line at that point. So wherever angles are being created, those angles should add up to 180 degrees. So it's an equation that you have formulated. So here we've taken this from angles on a straight line. So here it goes about the angles on a straight line. So like I said, angles on a straight line add up to 180 degrees. All right. So these ones, they add up to 180 degrees. We know that, right? The interior angles. So it is of this nature that you formed an equation that you're supposed to solve for x, because already we have everything in this case, like we have everything. So we're going to simply add, collect your leg terms, the terms with x together. That is going to be x and x, which is 3x. This is the same as 1x. So it's 1 plus 2, which is 3x plus 90 degrees is equal to 180 degrees. So that's 3x is equal to 180 minus 90. If you transpose 90 to the other side, there it becomes what? It becomes a negative. So that is going to be a minus 90 degrees on this side. So 180 minus 90, that is 90 degrees. You can divide by 3 since you're multiplying here. Divide by 3 both sides to determine the exact value of x. So this was going to give you 30 degrees, or you can just use your calculator. Like I always say that the calculator can be used whenever you do not understand your calculation. So just divide 90 divided by 3 like this, that is a 30 degrees. Okay, so this was a straightforward calculation. So with this information that we have, let us try to bring it on the diagram and see. X is equal to 30 degrees, all right? So if x is equal to 30 degrees, it means here there's a 30 degrees that you're going to have, right? Let me just put it this way. There's a 30 degrees wherever there's x here, there's an x here, so this will be 30 degrees. Here also we said E1 is also equal to x, so it means this will be 30 degrees. 2x means 2 times x, that's 2x. So it's 2 times 30 degrees, which is 2 times 30, which is 60 degrees. So this will be 60, and this will be 60 degrees, okay? And yeah, that's it. You can just substitute that one. Okay, let's see. So the other question was to prove that ABCD is a parallelogram, okay? So remember the major property of a parallelogram, like we were explaining. Okay, let me just remove this part so that we can properly have our question answered here, because this one is a nice question. It's very, very nice to have this type of a question before exams, because they do ask this type of a question. All right. They are saying we are supposed to prove that ABCD is a parallelogram. Okay, this is what we have. This is ABCD, the whole of this shape. From the look of things, we can actually see that the opposite sides, they are parallel. These two sides, they are parallel. These two. We are told that these two sides are equal. It does not give us that allowance to say it's a parallelogram as such. But remember what we explained here. I want us to go back here so that we can have our proper understanding. We said a parallelogram is the mother quadrilateral of a rectangle, a square, and a rhombus, for the fact that opposite angles of these quadrilaterals should be equal. So by just having this, it means I have a parallelogram, because a rhombus is a parallelogram. A square is a parallelogram. A rectangle is a parallelogram. But in which manner? That is the most important part. In which manner? So we are going to prove from the angles, because what we know is that this angle at A must be equal to the angle at C. The angle at D must be equal to the angle at D. If that is so, therefore this shape that we see is a parallelogram. So that is what exactly we are simply going to prove. All right, so this is 5.22. So we are simply proving the angles here. If we can prove any of these, simply prove that angle A, all right, I can talk about angle because D is actually easier to work with, but I'm going to talk about A also. One D, not A. Angle B and D. If we can prove this, that angle B is equal to angle D, we are done. If we can just prove this, we are done. So can we prove this? Because that is the major property of a parallelogram. Opposite angles should be equal. So these are the opposite angles, B and D, A and C. So it's either I'm going to prove B and D, or I'm going to prove A and C, A to be equal to C. All right. So let's prove. Let's start with this one. We want to prove that angle B is equal to angle D. Once we can prove this, it means this is a parallelogram. Okay, also. Already angle D is 60 degrees, all right? Then at angle B, we have got angle B1. We are given already this is 30 degrees. Okay, B1, this one, which was equal to X. Then we also have angle B2, the next angle, this one. If you consider angle B2, you're going to see that it is the same as angle E1. They create a Z angle like this, alternate angles. From the parallel lines, the angle E1 and this angle are equal. They create a Z, right? This angle are equal. So meaning to say, angle E1 and angle B2, they are equal. So if angle E1 is equal to angle B2, it means this is equal to 30 degrees, because remember, E1 is equal to X. So this is equal to 30 degrees. So meaning to say here there is a 30 degrees at B1. So the whole of angle B, which is a combination of B1 and B2, is going to be 30 plus 30. And 30 plus 30 gives us 60 degrees. That's the angle B. The whole of angle B here is 60 degrees. All right. And also, the whole of angle D, we said, is 2x. And 2x is equal to 60 degrees. So angle D being 2x is equal to 60 degrees. So there is no way that this can be 60 degrees and this also be 60 degrees, these two sides being parallel. And this is not a parallelogram. There is no way. So by having this it means that ABCD is a parallelogram. Therefore, ABCD is a parallelogram. So for you to know for you to prove a shape, you must know the properties of that shape. You must know the properties. So this is a parallelogram. So the condition there is going to be from what? From the fact that we saw that this is opposite angles equal, right? So opposite angles equal. So meaning to say our opposite angles are equal. And that is the major property of a parallelogram. So like I said, we can prove from this, or we can prove from the other angle if you wanted. Could you have worked with angle D, angle A and C? From angle A, we can calculate that. To have angle A, angles in a triangle, remember they add up to 180 degrees. In triangle ABE, that's a triangle, you're gonna have A as 180 degrees minus, we subtract 30 degrees and also subtract this other 30 degrees because you know that angles in a triangle add up to 180. So this is going to be 120 degrees. All right. What about the angle C? Okay. For the angle C, we have the 60 here. So we can calculate C1, this C1 here. So angle C1 is going to be these two angles from 180. Again, angles in a triangle, remember I said they add up to 180 degrees. So meaning to say angle C1 is going to be 180 degrees. We subtract this 60 degrees. We also subtract this 60 degrees. So this is going to give us 60 degrees. That's 60 degrees here. All right, what about angle C2? This angle C2. Angle C2 and E3, they are the same, okay? Considering the Z angle concept, parallel, as you can see, you're creating a Z. So the angle at E3 and the angle at C2, they are equal. They create a Z, alternate angles. So this is equal to angle E3, which is equal to 60 degrees. So therefore, the whole of angle C, if this is 60 degrees, it is going to be 60 plus 60. You add these two. So that will be 60 plus 60, which is 120 degrees. So as you can see, the angle at A, right, is angle at A. And the angle at C, they're the same. The angle A, which is opposite to angle C, are equal. And opposite angles, once they're the same, this is a parallelogram. So from the concept, it therefore follows that ABCD is a parallelogram. All right, so this is how we could have worked from this. And the same reason, opposite angles equal. As you can see, angle C, angle A is equal to angle, we've proved this. Angle A is equal to angle C. So when you are proving, you know a certain concept already. You have studied the theorems. So you know the concept of something, you know the properties of that shape. So you use that to prove, because it is, you don't prove like you already like what can I say? You already understand it, no. You know a certain property which is true. I know, okay, the properties of a quadrilateral, which is a square, a rhombus, each and every quadrilateral, you're supposed to know them. So in order for you to prove that this is a square or this is a rhombus, you must have those properties in you. The properties must be within you so that you'll be able to prove, right? So I want you to study the properties of each and every shape that I've listed, all right? You must be able to know for the parallelograms, which I said for a parallelogram, the properties of a parallelogram are the ones that you also apply on a rectangle, are the same properties that you apply on a square, are the same properties that you apply on a rhombus. All right, this is the mother of these ones. So they follow all the properties that we have, except for a rectangle, we are going to see the interior angle being at 90 degrees. Also for a square, the interior angle being at 90 degrees. A square is also a rhombus, but they have this as the mother property. Then also, we have got a kite that you are also supposed to know its properties, and a trapezium. All right, but for the parallelogram concept, you are supposed to differentiate now that you know that they have the properties of a parallelogram, which is true. But how do I separate a rectangle from a square, from a rhombus? Those are now the properties of each. So I want you to study your properties, understand your properties as much as you can. This helps you to answer as much questions as you can. As long as you understand these properties, you'll be able to attempt any typical question in your syllabus. All right, so let's revise as much as we can.